In this first example, you're given graphs A, B, C, and D, and are asked to match which of these descriptions here go along with each graph. And there's two extra descriptions that don't go with any of these graphs. So, graph A, you can see here that this is behaving like a power function, because a power function is going to be of the form y equals a times x to the n power. This looks like a power function. This looks like a power function. These look like exponential functions. Exponential functions have the format y equals a times b to the x. One of the main characteristics that helps you differentiate between the two is that a power function is always going to pass through 0, 0. Because a power function doesn't have any other pluses occurring or anything like that that could make it shift up, down, left, or right. It's going to pass through 0, 0. Whereas an exponential function is never going to have a y value of 0. It will never pass through the origin unless there are some other transformations that occur that go beyond it being just a regular exponential function. So as you look at these situations here, this looks like a power function. It looks like it's going to have an exponent that's even, and I can tell that because the end behavior, the two ends, are pointing in the same direction, in this case up, and a would be greater than 0. This one's saying that a is greater than 0, but n is odd. You want this one here, so switching those two places and having n being even here, that's what graph A is. Graph B, at least the way it came out for me, it's going to come up in different orders for you. You can see this is an exponential function because you have that one side that has that horizontal asymptote, and it's continuously growing. This is a growth function. So this is an exponential growth function, so that one was already matched up correctly. Graph C, well, you still have that vertical, that horizontal asymptote on the right side. It's decaying. It's an exponential function, but it's decaying. So it should be an exponential decay function, so that should go here. And that would match up with graph C. And now graph D, you have the two ends pointing in opposite directions. It's a power function. It goes through 0, 0. So you know that the exponent n is odd. And because it's increasing throughout, that tells you that it's going to have an a value that's positive. So that one was already matched up. A is greater than 0, ends up being odd. And so that's the match there. These two, a power function with a, both the ones that have power functions a less than 0 are your instances that aren't being used in this particular question. Now for this one here, you're asked to decide which of these statements is true about these two functions. F of x is a power function, it's x to the 21st power, and g of x, which is an exponential function, 3 to the x power. Well, if you look at the graphs initially, and as far as you can usually get on the graph, you can see that this one's going to be the blue function, this one's going to be the red. This graph being a power function, odd degree, they're pointing in opposite directions. You see this kind of behavior, whereas this is behaving like an exponential function. So you can see that before you reach a point somewhere in the positive area, that g of x was greater than f of x. That's because mostly this was negative and exponential functions can't be. However, there is a statement that's in the notes as well as your textbook that basically says an exponential function will always overtake a power function eventually. So even though it looks like this is going up pretty steeply, this will continue to get steeper and steeper and steeper. It's just that you have to go a pretty far ways out for you to start seeing it. So if you were to take a look at these two functions, now first of all you can see that the red function g of x is not greater than f of x for all real numbers. You can see it is for some things, but then it isn't, because f of x right here is bigger than g of x. And certainly, even after you hit 0, it starts off that g of x is greater than f of x, but you do reach a point where they switch places. So these two are incorrect. And you can see that if you put some values in, at 0, f of x is 0, at 0, g of x is 3. So you can clearly see that f of x is smaller than g of x. But then when you hit this point here, about 1.0568, which you see appearing in a couple things up here. Now, this is about where the two are equal. You can see they don't look equal here because of the rounding error, but there's only a 0.15 difference between the two. I mean, right now it still looks like that f of x is smaller than g of x, but then when you go immediately to the value of 2, f of x is much greater than g of x. So they did switch places, and it was around here that they were about the same. That's why there's an asterisk here, because you're not seeing it being exactly equal because of rounding errors. So you can certainly say that from negative infinity to 1.0568, g of x is actually greater than f of x. So this statement up here is false, because this is, here it's less than, or g of x is less than f of x. Here it was greater than. So you did have a switch over, so this one doesn't make any sense either. This one is the statement. This is only going to happen from here at about 1.0568 until you hit about 84.89855. Because if you look at that, now here in the asterisk, this is about where they should be equal to each other, but you're seeing there's still a difference. And because you're dealing with scientific notation numbers at this point, and such large powers of x involved in both cases, it's going to be somewhat problematic for you to have any small difference in the x value not make a massive difference in here. However, if you would go another point out, you would see that, like maybe at 85 exactly, this would again be a situation that is going to be smaller, or is going to be greater than this. So this will eventually be bigger again. And so that's this statement here, that f of x will be greater than g of x between these two values approximately. And so that is the end of this problem in this example, and that is the end of this video. If you have any additional questions, please bring them up during class.